So this is where we left off on this rotor. Now we're going to flip it around in the same collet, and we're going to do the same thing for the other spindle. Let me get you a close-up on that machine finish that we just got. So that is our bottom side spindle. So that is the taper, and that is the recess that's cut between the bottom bearing journal face, and then most of this outside face will get turned down, and there will just be a small lip that we will relieve, just so if this rotor ever wears that much, it won't be contacting this outside face on the bottom of the bearing. So we're going to flip it around. It does not matter how far you have it in the chuck here. We're going to do the same exact thing as we did before. We are going to give us a little scribe mark at about 170 off of the port. That is just an approximate point again. And then also I'm going to, since we have to turn this down to final length, I'm going to do 170, and then the length of our spindle, as per our drawing here, is 1/4 of an inch. That's the length of our top spindle. So 250 thousandths plus 170 thousandths, which is about 420. So I'm going to put that scribe line too, and that's what I'm going to work towards. I'm going to part off, just after that line to get us an approximate final length that we'll turn down to finish. So. Get up to 600 RPM. Jog over and line up my scribe line with the tool. Okay. Lock down the carriage. Okay, we're going to part this off. Those are the scrap in. Okay, so now we have our approximate length. It's plus or minus, well, it's actually over 10,000, or no, sorry, it's not. Plus or minus probably 5 thousandths on that scribe. We can actually measure it real quick. Yeah, so it looks like we're over about 2 thousandths, which is perfectly fine. That'll give us enough room to face off. So then we're going to swap out our tools. This is actually a new tool I tried today, and it's really nice. It leaves a much better finish than the one I was using before. So this is Braze Carbide. This is from McMaster Car. Yeah, I think it was like $7. Really, really nice tool. Okay, so let's find our scribe line again. The first scribe line, and I'm just going to press the tool up and give us a mark. Okay, so we're going to turn that face down to 1/4 of an inch. This tool breaks the chip a lot better, and it's pretty difficult to do in brass, especially using the carbide insert tooling. Take some pretty aggressive cuts here. It'll do it. Pretty cool chips. I'm actually going to up the RPMs to 960. Okay, so that should get us close. So we're sitting at about 285, 286. Our final dimension on this spindle is 248. So this top spindle is a cylindrical spindle. It's not tapered like the bottom, because as the rotor wears down into the casing, we don't want the top spindle to become loose, which a lot of valves from pretty prominent valve makers have top spindles that are also tapered as the bottom. Because this is tapered and this is a cylindrical. So as this rotor wears over time, over years and years of playing, if it gets, wears that much, which it really shouldn't, the reason this is tapered is because this bottom will continue to seat down and seal as it wears. Same with the face of the valve. But if your top bearing is tapered a cone that way, it does not make sense to have that tapered for wear, because then as the rotor wears down, you'll have a bigger gap on the top, a bigger gap between the rotor and the bearing. So, what did I say we were at? We were at about 280. Okay. So, take some light cuts. I'm going to do 15 and 15. See how that turns out. 248 thousandths is a pretty tight tolerance I like to keep, because the actual bearing will get reamed out to 1/4 inch on the dot, so that 2 thousandths gives us that rotating fit. And I just lost a 0 from touching the dial, but you can retouch off and take a small cut. So that dimension is +0 minus a half a thou. There's anything over 248 thousandths and it will not move in the bearing. It'll take a lot of lapping to get that to fit, and that's just not a very repeatable way to go about it. So we're at 256. So since this is brass and this is brass carbide, we can actually sneak up on it. So I'm going to do 3, maybe 4. That should get us down to just over 1/4 inch. And then we'll do 2 more cuts to get done size and mic it. Yeah, so we're at 253-ish with the calipers. I'm going to start miking it. After this one, I'm going to go 3. Okay, so we're spot on 4 right now. Okay, so this is showing about 251.5. This should be our final dimension, and then we will cut the recess. Cool. So that's on size. I'm going to cut that round fillet, and then I'm going to center drill this for the preface for cutting that taper. And break the edges. So we're going to lower the speed to about 196. Set up this tool right there. Lock down the carriage and use the cross slide or the top slide. Since this is a form tool, you have to bring the speed down a lot, pretty slow, and then you're going to take light little pecks. This is solid carbide, this tool, so it can take a bit of force, but you don't want to bury it in there, especially with brass, because it'll bite. As soon as we get a full depth in there, I pull it out, and then I'm going to use this same tool to break the edges up to 600 RPM. Just give that a nice chamfer. don't need to break the outside edge because it gets turned away anyways. So now we are going to actually center drill this. So just like the other side, we're going to come in and use that same center drill just to give us a nice center. And this center will be left on the final part